just to introduce myself, I'm Alan Tan, originally from the Philippines. Okay, so I don't know if I can. Next time I'll try to speak in Chinese. So that's the goal. Okay. So my presentation today is at least an example of the ModSim, right? The modeling design or modeling and simulation, but it's an example of a tire design. Okay. So hopefully we can learn more and how do we apply it in our work, right? Okay. So you see, I mean, we try to make it nice. So rolling into the future, how do we use ModSim to drive better and faster tire engineering? Okay, I did some agenda. So I divided it into unified modeling and simulation, tire engineering design, okay, requirements and test management, tire design with ModSim, finally AI and machine learning where everybody wants to see what it is, and summary, right? Okay, let's go to the modeling and simulation. So why do we want to do ModSim? Is first we want to accelerate innovation. I mean, there's a lot of complexity. Tires are very complex materials, right? You have different layers of tires, different layers of rubber. Then you have probably rebars, steel inside. And there's a trade-off between the magic triangle. You know what magic triangle is? So it's the cost, time, and scope. Okay? The more scope you want to do, it becomes expensive, right? Or you need more time. The less time you want to do, less scope. Or less time, more expensive. So it's a triangle that we need to solve, right? Okay. And also the regulatory requirements. You need to have the regulations from the Federal Motor Vehicle Safety. There's the SAE standards. Okay. Then also high cost of involved in the product design testing. I saw in the presentations a while ago, we see a lot of design testing, prototypes. It's very expensive, right? And also, I was really happy to see the EyeSight, the DOE being used. Okay, it helps you to have more design exploration. Okay, if you have a good design exploration here, right, then you have better innovation. Of course, everybody wants to reduce the carbon footprint, right? So everybody is requested to do that. But at the same time, we need to reduce wear. We need to make the tire last longer. Okay? Okay. So as is, and I'm copying what the presentation a while ago. We have as is. So we have a project. Okay. You have a CAD geometry. You exchange files. Okay. You export or import. Okay. You have files in your hard drive. You do meshing, create, pre-processing, right? Then you do another export or import, okay? And you have a lot of tools. You have probably 3 or 4 simulation tools. Then you predict, right? So that's as is. So what if you want some changes? Okay? So these are disconnected. Everything's disconnected. Okay? And then if you change, you repeat the process. Okay? So you do it again and again. And sometimes this takes very long, right? Creating a new CAD and everything, right? So in our case, we see in some of clients, you see 20 specs per engineer per year. Only 20. Okay? And in the unified modeling and simulation topic, we look at this as in here, you have modeling simulation and the design exploration. Okay? You want to push all of this here, right? And a lot of the capabilities as well that we want to add. Okay? So that's the modeling and simulation. And you can do more design and exploration. Okay? Then because of that, we can include automation. So it looks like what was shown a while ago, but it's now in a different form, but it's EyeSight. You can do DOE here, do a lot of study, right? You can also look at the requirements, KPIs, and project management. Okay, so I'm trying to hurry up, but I'll explain more of that details later. So the most important thing in the ModSim is CAD and CAE model are interconnected. Okay, so they're interconnected. So you can no doubt design for many topics, right? It could be performance, safety, and manufacturing, or anything else in between, right? You might want. And the results, okay? Then this is what you call the ModSim in 3D experience. Okay? Once you have run or created all of this in the system or in the platform, any design changes, anything, is just one click. Okay, you click it once, then you don't need to recreate the mesh, no need to recreate the case, like load, no need to do that. It's rerun automatically. Okay, that's the big thing here. And you can also do exploration and design, and all of this are automated, and you can create comparison, right? So that helps you. I remember the saying a while ago, somebody presented, what did they say? Hard work doesn't mean success, right? But I think the Chinese word is better. What? 用功不确定成功, right? That's what they say. That's what I remember, right? So I like to create mesh. I remember when I successfully create mesh, I'm happy, right? But it takes 1 week. I'm so happy, and I said, I need to rest, right? But then I need to run the analysis, right? So again, right? 用功不能确定成功. Okay? So how do we determine success? Is we do more design, right? So again, if you look at the tire engineering, we have the design capability. So how do we make us as system analysts, as FEA experts, right, or CAE experts, to be more successful? Is by including the design. Right? If I do an analysis and it's not used for a design, it's useless. Okay? So what we wanted is the simulation will drive the design, not the opposite. The design will tell you what to do, then let's change, design will tell you another thing. But it should be opposite. Simulation should drive your design. Okay? So we look at this in the industry process experience. So you can include all of this, what you call methods. Okay? So in this case, it could be heat generation, noise and vibration, very close to as a laptop, right? Similar, but different industry, but you still have noise, you have heat, very close, right? Aerodynamic, you don't need that, but shaping, footprint, force, hydroplaning, plunger test. So you can all include of this as part of your design process, right? So in this example, we can also enable a virtual test lab. So you can see here. Let's just look at it. So this becomes a virtual twin. You have a test lab that's similar. So first is lateral slip. You can see we can change in the virtual test lab. Okay. And then you can look at the stresses. Okay, different angle, probably different forces. Okay. It's another contact pressure. Then you can see the same thing, right? You can also look at the mesh, but if you report to your management, it's better to look at something like this, right? It looks nice. Plunger test, like you hit it with something. The plunger, yeah, you can see displacement, force, and also simulation results. Okay. So you look at the inner belt, the force in the inner belt as well. Okay, another footprint test. Okay, we just look at the footprint at a certain MPA, like you can see how it looks like, right? Again, other testing can be done as well, right? So pendulum test is one. Okay? So if you can do a lot of this virtual testing, then it also reduces your actual testing, right? So pendulum test gives you those, right? And I continue on. Then the design can be for performance, okay? So in this case, you can look at the performance, right? So type footprint, you have include design exploration, but also different parametric model. So one of the advantages of creating a parametric model in your CAD, so different values, you can change it quickly, and you can get more simulation and run DOE efficiently. Okay? So this is an example of CAD and CAE mesh associativity. So let's look at that. So you can see, if you have parametric model, like I change the width, thickness, belt overlap, the overlap between belts, so you can see the changes in here, happening here. It's updated, the mesh is updated as well. Okay. Any changes there, updates here as well. Okay. So that will help you create what we call the DOE easily by just changing your parametric model, right? So this is another example of what's happening here. You see, I can change many things. So this is the simulation now. You can just run it. We get the results quickly as well. You can run a symmetric model, different degrees, right? Different angles. So you see the results quickly as well, right? Of course, that takes time to solve. We haven't shown you the solving part, but yeah, we do a lot of this quickly, right? So that's how you connect the CAD mesh, the materials, and no changes in your forces, loads, and everything as well. Just change one thing and everything goes. Right? Then you can also add DOE. Again, if you add DOE, then you can just run it again here, right? So this is an example of how to create DOE. Just create a DOE, put the simulation there, footprint analysis, and you use tire inflation in your DOE. You use knowledge parameters. I say, what are the parameters I need to change in your DOE? What analysis I need to check? Okay, so I'll choose a tire footprint. Okay, then sensors, like what are we looking at? Less mass, lighter, right? Then you can choose a type of DOE. Are you doing full factorial, different points? What values are you looking at? So it will create different results or different parameters for you to run. And if you run it, when you choose DOE and run it, it gives you different values of your parameters, right? Give you different results as well. Okay, and somehow it should show you, go into the results analytics, it analyzes your DOE. Okay, so your study will be, you just read the analysis. Okay, and I mean, what are you gonna minimize? Minimize mass. Okay. You want to compare, so then you can compare. Okay, so that is a power of having DOE. So you run many and you can compare. So it's similar again to what you have in EyeSight, right? But here, everything is created very quickly. Right? Okay. Again, you can do design for safety. Okay, again, the plunger test is a design for safety topic, right? So here, that's what it looks like, right? Okay. Okay. But again, in our case, we don't only look at simulation. It could be for manufacturing. How do you manufacture this thing, right? So this, again, is not pure simulation, but how do you manufacture? It can be connected on curing, right? Shaping simulation. How do you shape this thing? Okay? So here, example of that as well. So how do you shape this? And so when you create it, you need to put pressure, you push it on the side, and then you create the shape. And so that's the actual shaping, and that's what in simulation looks like. And this seems to be very useful in tire, very important for them, right? I think it's also important for you, some of their topics, right? In shaping and everything. Okay? But all of this you can connect to a requirements and test management. So how do you connect them? So in the same case, you can look at your testing, test management. What's your minimum braking contact, tire mass, and stiffness, right? These are the requirements, test cases design, and you can connect it to the ModSim. Okay, so you can have verification, validation, everything to pass the KPI, right? So in this case, it's a rolling resistance, it's plunger test, you just include that in your process. Okay, so looking at all, again, tire design with ModSim includes all of this. Again, as I've shown, it's more of a left shift, and I like your presentation on left shift. It really cleared my mind. Why are we shifting left? Right? You want to do more work initially, but you don't want to do more work in meshing, right? You don't want to do more work on simulation as well. So you left shift, not effort on meshing, geometry creation, right? Effort on more results, okay, more analysis. So we always say simulation powers innovation, okay, but ModSim accelerates innovation, right? That's what we want. Okay? So again, we want to do the mod shift, and the benefits of doing the left shift is that this is an actual case. We look at a tire company, okay? So they improve design robustness, but at the same time, because of increased efficiency, instead of 20 specs per engineer per year, you can do now 100. Okay? Then they used to have 2 months to generate green tire specs. Now it takes a week by automating the engineering processes. Okay? So efficiency, automation, that's a big benefit. Okay? But as Klaus has presented, where can we help more in the future as we go to the AI machine learning stage, right? So what can we do? So it's a ModSim driven AI, right? Can we add AI? Okay. And it looks the same as well, right? You have design exploration, but AI needs training. Okay, either we do it for you or you do it yourself. But if you do training with creating your mesh, creating your geometry, again, it's useless, right? So if you include everything in the design exploration stage, then, as I've said, we shift a lot of the creating the training, exploration to ModSim, and then we can do a very fast analysis with AI or machine learning, right? So in this case, this example, for Abaqus, it takes 1 hour with 36 CPUs. With 1 GPU, it takes 2 seconds. Okay, but of course, you need to train it. But training, once you've done a lot of training, this becomes almost instantaneous, right? So I remember I have a client who goes to a meeting, and they said, what if we change this one? And the engineer will say, okay, give me 2 weeks. I need to come back, mesh it, give you the results, right? But if you have this one built in the ModSim plus AI, then you say, okay, if you change the thickness of this one, this is the result in a meeting, right? So then you're bringing only an iPad or a Lenovo machine, right? No need for an HPC, okay? So that's what a ModSim-driven AI will help you, okay? Okay, so it's 3 simple steps. You need parametric model, which is important, or many models, okay? Training. So you can create your training in the DOE tool, Process Composer, right? And it could be a web-based UI. Okay? So Klaus have shown this one, okay? The one click and gives you the results quickly. So you can change components, chord length, the arc, radius from thread 1 and thread 2, step size, internal pressure, right? And change it to a different pressure. And as Klaus has said, press done, and it's done. Don't blink, right? It's already done. Okay, so that will help you, again, not only in designing, but also in meetings, right? You can explore many things in front of everybody. So that helps with your collaboration. And again, the results are Abacus view over results. Okay? So we did like machine learning on lateral slip. Those are examples like that we can look at, right? So Abacus results again, 2.7 hours on 64 cores. Okay? It's 40 seconds in 1 GPU. It's a bit longer, 40 seconds, but it's a whole results of in time as well. Okay? It's not a single result, it's a time result, right? Okay? So again, summary. I did fast, the business value. Okay? It multi-million cost savings per development program. Right? Again, 25% go-to-market time reduction. Performance. Okay? There's a reduction on rolling resistance. You have a better product. Okay? Improved fuel economy. Okay? But one of the biggest discussion that we had for you guys, the users, is you accelerate innovation. Okay? Make innovation faster. And democratization. You can now move a lot of this work to designers, right? So more people can do simulation now. It's not always bad, right? You become an expert and share the work, right? You democratize, right? And maybe you can do more interesting work as well. Okay, so that's, and again, ModSim is what we push for everyone, right? Thank you. 谢谢大家。